Okay, here is warm-up number 48. So this first batch of questions, or the left side of this, we're going to be just naming the segment. So it's the segment that's labeled with the letters, right? So we're talking about AB over there, ED, and so forth. So the ones that I'm highlighting are the ones that I'm naming. Okay, so let's start up here. Well, I can see that this bisects that angle at the top, so this would be an angle bisector. Okay. This one, this pink segment here, ED, is going to bisect the bottom, and it's also perpendicular, so it's a perpendicular bisector. Okay, this kind of looks, some people will go for perpendicular bisector here. It's perpendicular, but it doesn't bisect the bottom. Even if it looked like it did, if it doesn't have those two little marks, I can't assume that it bisects the bottom. But this is an altitude. It's the distance from a corner to the opposite side at a right angle. It's the perpendicular distance. So this is an altitude or height. I'm going to call it altitude. Okay. Next up, ED here is connecting two midpoints, and this is called a mid-segment. See, sometimes people go for median, but this is a mid-segment. A median connects a vertex and the opposite midpoint, which is exactly what happens right here, right? So this connects a vertex and the opposite midpoint. This one is going to be a median. Median and mid-segment tend to get mixed up. That's my experience, but there they are, okay? All right, and then this one kind of looks like a median a little bit, but I can't tell that those are congruent, so that's not necessarily a midpoint. And if you look really closely, it's a little hard to see, but those two angles are congruent, so this is an angle bisector. Again. Okay, all right, next up we're going to name these points of concurrency. So the points of concurrency, we're talking about where these lines meet inside of the triangle on all of these, okay? So key is I have to figure out what is meeting at those different places. So there's a mnemonic device. All of my children are bringing in peanut butter cookies. All of my children are bringing in peanut butter cookies, and that can help you remember what meets where. So if I look at this first triangle here, it's a little hard to see the little dashes, but this is an angle bisector up there. This is an angle bisector. And then over here, this angle is bisect. There's three little ticks in the corner over there. So that means these three dashed lines here are all angle bisectors. So this is where the angle bisectors meet. And this is where the little mnemonic device is going to come in. All of my children are bringing in, the are bringing in part, angle bisectors, AB. And then I know that the point of concurrency is going to start with an I, so this is going to be an in-center. Okay, next up. So if I'm looking at these line segments, like let me choose this one. This connects a corner to the opposite midpoint. I know these ticks are a little hard to see again, but this is a midpoint here because I've got two ticks at the bottom there. Okay, and all of these are midpoints. These points, S, T, and U are all midpoints. Just trying to make that a little easier to see. So they all connect a corner to the opposite side. This is where the medians meet. These are all medians, okay? So that's the M up here. So this goes with something that starts with a C. Now there are two choices, centroid or circumcenter, and you just got to know the difference because there's two C's up here, okay? So this one is going to be centroid. Centroid is where the medians meet. Okay, this one, let's see. So this line segment here is a perpendicular bisector, right? It's perpendicular, it bisects that side. All three of those are perpendicular bisectors, so that's going to be over here, perpendicular bisectors. The other C, so it's not centroid because we already used centroid, it's circumcenter. Okay, and then last but not least, so looking at these aren't perpendicular bisectors. Yeah, they're perpendicular, but they don't bisect the other opposite sides. But it does go to the opposite corner from this side. So this is going to be an altitude. So that's the last one. Altitude, it goes with something with an O. That's an orthocenter. Okay. All right. So next up, we're going to find the centroid. This is where the medians meet. If you go back and look above. So I could graph two of the medians or all three of the medians and find the point where they intersect. The problem is that with that is sometimes it's a pain to graph the median. It's actually not that bad. It connects a corner to the opposite midpoint, right? So I'd have a median going from this point to the midpoint over here. I could find the midpoint with a midpoint formula. It's going to be right there. So I would get a median that goes like this, okay? And then I could do that with another side, and hopefully it would meet right on the grid. But if it doesn't meet on the grid, then I've got to find the equations of, say, these two medians, something like that, and do a system of equations to find the intersection. It turns out this one is going to be an integer answer, so it wouldn't be that bad to graph it. I think if you did neatly, you'd be able to see where on the grid. But there's a nice shortcut. With a centroid, what you can do is just average the three x's. So my three x's here are 3, -4, and +4. So that means the centroid, I'm just going to average those three numbers. Now I have three things that I'm averaging, so I divide by 3 to average them, right? That's going to give me the x-coordinate of my centroid. And then if I average the y's, let's see, I've got 4 and -4 and -3. And again, I divide by 3, and if I do that, it's going to give me the y-coordinate, okay? So let's see, here the 4's actually cancel each other out there, so I'm left with 3/3. And over here, the 4's cancel each other out too, 4 and -4. So I got -3/3 is all that's left. So that is the point 1, -1, okay? And yeah, let's say I got the midpoint here would be there, and then let's see, just from a graphing perspective, if this looks right. And then I'd have to connect those, something like that. I'm doing this quickly, so I hope this works out. The midpoint of the bottom is going to be right here. Connect like so. And my last median, go from this corner to this midpoint. Hopefully it should go roughly through that same place. And yeah, this is the point 1, -1, so feeling good about that. But yeah, averaging the 3 x's and the 3 y's works really nicely on problems like that, especially if you get a decimal or a fraction. Okay, that's it for this warm-up. See you next time.